This time, what we're going to do is our June is going to launch an arrow with an initial velocity of, I want to try to get this right, 15 meters per second at an angle of 30.0 degrees above the horizontal. So you are launching an arrow at 15 meters per second at an angle of 30 degrees above the horizontal. I'll draw in a picture in a minute so we can kind of visualize what's going on. So Arjun, we'll do it here. So you are standing here, holding the bow and arrow, launching an arrow, well, like this. So you're going to launch an arrow. It's going to look like this. 14 meters away, horizontally, there's going to be a platform. On that platform, Mr. Palmer will be standing, wearing a helmet, a face guard, perhaps some baseball gear. On top of that, we're going to place an apple. And the question here is, where do we need to place that apple such that the arrow will strike the apple and the apple only? So what's the overall displacement in the y direction of the arrow? So we know the initial velocity of the arrow is 15 meters per second at an angle of 30 degrees above the horizontal. And we know the displacement in the x direction of the arrow is 14 meters. How would you like to begin solving this problem? Okay, sure. We have an object flying through the vacuum that you can breathe in 2 dimensions, therefore it's projectile motion. Therefore we need to list what we know in the x direction and what we know in the y direction. Tell me something we know in either the x or the y direction. Taylor. For the arrow, what do we know about the arrow? The acceleration in the y direction is free fall acceleration, negative 9.8 meters per second squared, because we have an object in free fall. Great. Who can tell me something else we know? More stuff. Mike. Change of position of the x direction or the displacement in the x direction. So the change of position is 14 meters. Good. More stuff we know. Please. Back.
It has a constant velocity in the x direction.
True, that's a known at this point. We could simply assume it has a velocity, a constant velocity in the x direction. Exactly. We need to know what it is, but yes, we know it has a constant velocity in the x direction. Other stuff, your shot.
Would the velocity initial be in the y direction? Because it's not.
The velocity initial, what's its value in the y direction?
15 meters per second.
This initial velocity of 15 meters per second is not in the y direction. Right. You're getting a way to solve the problem. We're not doing that yet. We need to just list the things that we know. The velocity finals, we don't actually know much about that. Katie.
Is the velocity initial in the y 0?
The velocity initial in the y direction is also not 0. We'll get there. It's not 0. It's not 15 meters per second. Mike?
15 is the hypotenuse of the right triangle at 30 degrees.
This initial velocity vector is a vector that's neither directly in the x direction or the y direction. So who can tell me what we need to do with it? Frederick. First thing we need to do is break this initial velocity vector into its components. We have an initial velocity at a certain angle theta. We need to figure out the initial velocity in the x direction. We need to figure out the initial velocity in the y direction. Remember, anytime you're given a vector that's neither directly in the x direction or the y direction, the first thing you do is break it into its components. Trevor, please break the initial velocity into its components.
Okay. So we know that theta is 30 degrees. So we can do sine theta equals opposite over hypotenuse.
What's opposite to theta?
Velocity initial y.
Over hypotenuse.
Velocity initial.
Therefore, the velocity initial in the y direction equals the velocity initial times the sine of theta. So we get velocity initial in the y direction equals 15 times the sine of 30 degrees, which I believe is 7.5 meters per second. Is that correct? Sine of 30 is, yes, 1/2? Okay. We do the same thing with cosine. Cosine of theta equals adjacent over hypotenuse. Adjacent is velocity initial in the x direction, hypotenuse is velocity initial. Therefore, the velocity initial in the x direction equals the velocity initial times the cosine of theta, or 15 times the cosine of 30 degrees. Velocity initial in the x direction. Could I please have that number? .990. So we'll just put 4 meters per second. So let's now list those as known items. So the velocity initial in the x direction equals 12.9904, and the velocity initial in the y direction equals 7.5 meters per second. We don't have what we're trying to find on here yet. Rachel, what are we trying to find?
We're trying to find the time. Wait, just kidding.
We will find the time, but before we, after we find the time, I'm just trying to get to where we're trying to end. So what are we trying to find?
We're trying to find the change in y.
The displacement in the y direction or the change in y. You actually should be able to look at the board right now and know that we have enough to solve for the change in y. Where do we start? Which direction, the x direction or the y direction? Jenny? Because in the x direction, remember, we only need to have 2 variables to solve for the time. So we start with the equation for the x direction, the constant velocity equation. The velocity in the x direction equals the displacement in the x direction divided by the change in time. We need the change in time. So please solve this equation, David, for the change in time.
All right. So if we multiply both the sides of the equations by the delta t or change in time.
So multiply both sides by the change in time. We get that the change in time multiplied by the velocity in the x direction equals the displacement in the x direction.
Yep. And then we divide both sides by the velocity in the x.
Dividing both sides by the velocity in the x direction gives us that the change in time is equal to the displacement in the x direction divided by the velocity in the x direction. But I'm confused, because we have the initial velocity in the x direction. We do not have the velocity in the x direction. Trevor?
The velocity is constant for the x direction.
Therefore,
The initial velocity is the velocity.
the initial velocity, because it's a constant velocity, is going to be the velocity throughout. It's the velocity in the x direction, it's the velocity final in the x direction, it doesn't matter. This is the velocity in the x direction. Therefore, the change in time is equal to the displacement in the x direction, 14, divided by the change in time, 12.9904. The change in time, please. Does it round to 7 at the end?
2.
I'll put it 2 then.
Okay.
That's fine. So then we know the change in time is equal to 1.07772 seconds. We're close to being able to figure out the displacement in the y direction. Susan?
So then you can use UAM equation for to find the delta y. And you would use delta y is equal to velocity initial in the y direction plus acceleration in the y direction times delta. Wait, no, just kidding. You would use delta y equals, that, and then times delta t, plus 1/2 a in the y direction times delta t squared.
We have all of this information. The velocity initial in the y direction is 7.5. The change in time is 1.07772 plus 1/2 times the acceleration in the y direction, -9.8, times the change in time again, 1.07772. That squared gives us the displacement in the y direction. please. Yeah, pitch.
The change in y is 2.39166.
Money. Thank you. So with sig figs, 2 point, what do we have, 15? So 2.4 meters. So we need to make sure that we place the apple 2.4 meters in the y direction above wherever our gene launches. Class, have I given you any new information today?
No.
Not really. What you should identify about today is that I've taken stuff that we've done before and combined it into something we're calling projectile motion. But really, projectile motion is just uniformly accelerated motion in the form of free fall and constant velocity, and the concept of the fact that time is a scalar, really. Right? So there's very little that's new today, just the concept of combining everything together. If you read through the book, they will try to tell you that there are like 12 or 13 new equations. Did I give you any new equations? No. There are no new equations.